Hello everyone, and welcome to another video for AP Computer Science. This video will be brief and will focus only on one topic in relation to how we store values inside of variables. So I'm going to make a new Java class. I'm going to call it Compound Assignment. So the topic is very simple. The idea is to give us more functionality in regards to when we save data into a variable, particularly with the fact that we often do arithmetic or mathematics in some fashion and then store a value into a variable. And on top of that, we often use a variable in a formula that refers to itself. So we'll see how we can use that to our advantage and shorten our code. What we're going to see here is not some necessary feature of a language, but an enhancement that's supposed to help programmers minimize how much they write, compact their thoughts into succinct formulas without overcomplicating things. So let's go ahead and make a main function. There it is. Let's make some variables. So let's go ahead and say int x is equal to 15, int y is equal to 10, and then now let's go ahead and make a variable z. And remember, we can initialize it by directly assigning it as we've done in these three variables. We do not have to declare them and then assign them. We can do it all in one line. And so I'm going to go ahead and say z is equal to z plus y. Oh, no, sorry, I'm sorry. This is a mistake. I meant x plus y. So if we were to ask ourselves what value does z have, I'm going to go ahead and print that out. We should see x plus y, which is 10 plus 15. We should see 25. So everything here is kind of already what we've seen. We're going to move on briefly, once we're confirmed that it is 25, into the new topic. So a compound assignment operator is essentially the blending of some simple arithmetic operator and an assignment into one line. So this is similar to initialization in that it's trying to shorten how much work we have to do. We don't have to write multiple lines to do the same thing. So as an example, one thing that we might try to do is say, well, if z has the value 25 after line 10, then maybe we want to say, I want to add 5 more to whatever z is. So if we were to express this in kind of a long form, we might say z is equal to z plus 5. So whatever it was, plus 5. And then once we have this new number, we reassign it. So there's nothing in the language that says a variable cannot refer to itself as long as that variable has a previously known value. And so in this example, because z was already 25, we add 5 to 25, we get 30, and we store 30. And because assignments erase what was previously there, that old 25 is no longer saved. The new value of 30 is saved. And that's a pretty important idea. Now, do we have to do it that way? No, we could write like this. We can always make new variables, but often reusing variables is convenient. Having to constantly make variables, one, does take up RAM, and two, it can get confusing when you have hundreds of variables, especially when their usage is very simple. The idea of summation, of adding to a kind of a compound number and building up to a final result, is very much reusing a variable. So the idea of summation is something that it would be difficult to do if we kept making new variables every single time we did an addition or a multiplication or whatever it might be. And so to shorten this, compound operators blend. So I'm going to go and write that compound operators. They blend an arithmetic operator with an assignment into one kind of shorthand line. I'll point out that there is no fear of something going wrong, because especially when it comes to reusing a variable, because the arithmetic must happen first. Our order of operations that we don't remember says that assignment is essentially the weakest operator in precedence that we've seen. So everything happens before assignment. So the ability to access z before we save z does not cause a problem for what it's going to be. We don't care what it's going to be until we assign it finally. We don't know what it is, and it's not very important. So now, for example, to rewrite the same line, I could use, and typically compound operators are very simple. They're the arithmetic operator you want and an equal sign next to each other. So for example, we could say z plus equals 5. Right? So this is equivalent this is exactly the same as line 13. So if we were to print z here, then we should see 35. Why? Because we said z is 25 plus 5 is 30. 30 is remembered. And then we came down here and we did the exact same thing. It may look shorter, but we're saying take whatever's on the left, add 5 to it because of the plus, and then reassign it. So it's kind of the arithmetic and then reassignment. So we should see 35 in the second print. And there it is. And so we can do this with every arithmetic operator. So let's try it out. Let's go ahead and say z minus equal 10. And then if we print, we will see the same value, 25, again. And there it is, because we said take z and subtract it. So I'm going to write the long form real quick. Z is equal to z minus 5, right? And again, the variable does not matter. It allows us to kind of say whatever variable it is. This works on ints and doubles, on shorts, on longs, on floats, and all the primitive data types that may have arithmetic applied to them. So let's do a few more. Let's say z divide equal 5. So if we print now, we should get 5 because 25 divided by 5 is 5, and then we reassign 5 to z, and then we print it, and we should see 5 as the next number. And there it is. We can do a multiplication, it's the same thing, so we could say z times equals, their asterisk is our multiplication symbol, times 10, and then we print it, and we should get 50. And there it is. And the last one, is the modulus operator. So we can also do modulus. We can say z mod equal, let's do something like 17, right? And so what would this be? 17 goes into 50. If we multiply it by 2, that would be 34. It would be, I think we're going to get 34 minus 50 is 16, I believe. Maybe I'm wrong. Or 15? No, 16. Yeah, there it is. 16. And so again, the modulus is the same thing. We are reassigning, and I'll put the long form for this one just to be clear about. They're all the same. We're saying z is equal to z mod 17. And now that said, we have to ask ourselves, what is the precedence of the compound operator? And thankfully, it's a pretty easy answer. The answer is the same very weak precedence as a regular assignment operator. So if I were to do a more complex formula, for example, z is equal to z plus equal z times 2 minus 5 mod 2. And let's go ahead and do this. Put a parentheses in the front, parentheses on the end, and let's see what we get. So if we ask ourselves, what is the result of this, and we print it, the first thing that occurs is the parentheses. Z at the last component, the last assignment was 16. So 16 times 32, 16 times 2 is 32. 32 minus 5 is 17, or 27. 27 mod 2 is 1. And then we add 1 to whatever z was. So this is plus equal. So now z was 16, so we should get 17, I believe, as an answer. And there it is. Right? So all this arithmetic, the precedence rules still apply. They're all more important than the compound operators. Compound operators are just as weak as the regular assignment operator. Compound assignment is the same level of precedence, which is very low. It's essentially the last thing to occur in our precedence right now. So if we were to go and write our list of precedence operations, I'm going to go ahead and find it. I believe we have a relatively recent list right here. So I'll copy it, and I'll go ahead and put it into our precedence here. And we'll say at the very end here, we can include not just the assignment operator, but we'll say compound assignment. Okay, and that includes all the ones that we saw: plus equal, minus equal, divide equal, times equal, and modulus equal. Right? So that's all of those, and they're all right associative. They're all very weak in their precedence order. I think that pretty much covers it. And again, do you have to use this? The answer is no. But it can become shorthand easier. Actually, no, there's a little bit more I want to show you. 2 more operators that are also very useful, and they're very much related. But the idea is that what I've shown you is not necessary. It is just an extra feature if you want to use them. The next 2 operators we're going to see are so common that we tend to use them whether we would like to or not. Even if we prefer the other style, they're so small and simple that it's worth. And you will see code both on the AP exam and that's written by most programmers that have these operators. So I'm going to go ahead and do it. So the idea of adding a number and reassigning is very common. In fact, adding 1 and reassigning is so common that there's a third approach. So right now our z is 17, but if I wanted to write, I could write the same thing 3 times. I could say z equals z plus 1. And that would add 1 to it. That's one way of writing the addition and reassignment of 1. The shorthand we just saw was the compound operator, so plus equals 1. And this is also very common. In fact, it's so common that even this is still too long for lazy programmers. And so there is another operator called the increment operator. So increment, which is the 2 pluses next to each other. And all we have to do is, and it will say adds, so let me point out what it will say is adds 1 and reassigns. Variable. And that's the same as what the compound operator does. And so we can do this example z plus plus. Now I'll point out, and some of you may know this if you've experienced in other languages, but I'm not going to use them. There are 2 forms of the increment operator. There's the one that I'm showing you now where the plus plus is after the variable. And there's another one called the oh my goodness, I forgot the word. I guess a pre-increment where it happens, the plus plus is before the variable, right? There's a post-increment and pre-increment. We're only going to stick with the post one. The one that we're going to see the most is where the plus plus is after the variable, right? And so we're saying add 1 to z and reassign it. And so this is much, much shorter than both of these lines. They all do the same thing. So if we were to print z, let me go ahead and copy that line so I don't have to rewrite the whole thing. If we were to print z, we should see 17 plus 2. We should see 20 because this one added 1. That made it 18. This added 1 to 18, which made it 19, and then this added 1 to 19, which made it 20. So we should see 20. And there it is. And in fact, the same thing applies for bringing a value down by 1. Subtracting 1 and reassigning is so common that there are 3 forms of that one. So let's do the same thing. We'll say z is equal to z minus 1. That's the typical original approach. There's the compound operator, which is minus equal 1. And then the decrement operator. So I'm going to copy this, and we'll go ahead and do that. And the decrement operator is simply, 2 minuses next to each other, and subtracts 1, subtracts, and reassigns it. So we can go ahead and do that, and we can say z minus minus. And again, there is a pre and post version of each of these, where you put the minus minus in front or afterward. We will only be using the afterward. If you're curious about the pre-version, we can talk about that maybe at some other time. But the AP exam will not question you on the pre-version. They're only really concerned about this post version of the plus plus and minus minus. So this is very convenient. And now, again, if we print out z, we should be back to 17 because we took 20 and subtracted 1 and reassigned it. That's 19. We took 19, subtracted 1 and reassigned it. It's 18, and then we subtracted 1 and reassigned it, and we get 17. So we should see 17. And there it is. And so these are not considered compound operators, but they are important operators nonetheless, the minus, minus, and plus, plus. In our precedence, they're actually more important than assignment because of the way they work. And I'm not going to do it just yet, but technically speaking, we are able to stick this increment and decrement operator in the middle of arithmetic. And it's quite possible to do, and if you're comfortable, it's not a terrible idea, but generally speaking, some people have the thought that it's not a good idea to do that because it kind of blends what your intentions are. Your intention by doing plus plus is to reassign a value in some fashion. And doing arithmetic also is changing a value by adding or subtracting numbers. So it can get confusing if you're not really comfortable. And the question is, what happens first? And so if we're curious about the precedence of plus plus and minus minus, they fall into the same category of unary operators as the negation and positive symbol. So now we can include negation, increment, and decrement, right, which are plus plus and minus minus. And that's pretty important. And we may not use that directly, but it's good to know that we have that option. More often than not, the AP exam will usually do that on their own. So So the video is going to stop here, and we will continue with a new topic in our next video.